All right. Good morning. Uh, this is day 5 of my. There's a 5 on there somewhere. Of the our break of our shelter in place. This is. I'm going to work through the problems that I didn't finish last time, and take some other questions. I got another question that's sitting over there. We've transitioned out of my living room into the well, I call this my brewery, I guess. So if you hear some weird noises and stuff, that's kind of stuff that's going on. I got some other cool stuff over here in the corner. I got my duck calls and wait, there was my duck calls and my drinking horn because that's what I have. All right. Let's work through the problem where I ended up last time. This is the 3 charges. Oh, I also have a whiteboard. I'm pretty excited about that. And my whiteboard markers. A couple things before we get started. AP, check your school loop. AP Central has made a current ruling, so about what they're going to do. The gist of it is that they are going to continue to move forward, and you're going to do a free response, a 45-minute free response exam at home. I don't think that's going to work, but I don't think lots of things are going to work. We'll see how it goes. That's today's truth as we're going forward. So again, be flexible, to kind of see how that goes. And yeah, with that, here we go. So also, yeah, that's it. Okay. What do we got? So we got the 3 charges. Oh, I did not get the problem number on this one. Let me double check real quick. This is chapter 18, 72, chapter 18, number 72. On your web assign, this is number 21. Sorry about that. Thank you, Sparsh. I had your thing covered up. Here we go. This is where we left off before, and because we had done part A, now we're doing part B. Looking at B, there's our free body diagram on where things are located. I did it in a slightly weird way last time. I thought it made sense to me. Turns out a couple comments and a couple other things. If we just did a standard setup XY axis, then it helps a lot. You can figure out what those angles are. We know that this angle here and this angle here is 60% or 60%, 60 degrees. Let's see if I can move this in a little bit more. Okay, I think that's a little bit better. That's 60 degrees, that's 60 degrees. And so now we can do the sum of the forces in the x direction and the sum of the forces in the y direction and work ourselves through there. So in the x direction, we have FBA in the x direction, FBC in the x direction. I'm going to make this way positive, just so these turn out to be positive. And then you can see that this is, there you have that one, and then we have that one. That is FB in the x. This is the cosine. This turns out to be FBA cosine 60 equals FBC cosine 60, and we can just add those together. In the y direction, sum of the forces in the y direction, all right, that's going to be this positive. However, FBA, force on B from A in the y direction, is negative. So if, oh, I did the, whatever. FBC sine 60 negative FBA sine 60. However, the forces are KQ1, Q2 all over R squared. FBC equals FBA. The sum of these add up to 0. So that's, thank you, Atisha, for that. And I think we completed this one already, just to kind of let you know. I kept all these papers, so I look like those crazy scientists from the all those science fiction movies. No, you gotta believe me. Yeah, so it should have ended up with 262 and some of the forces on A. We did that one already. And B is floating around in here somewhere. All right. But now we're gonna do to C. You should be able to take it from here. Part C. Again, you want to draw that free body diagram. Especially now that we've gone, the College Board is going to give you a free response question where you're going to have to write it out. And it's either going to be monitored, or you're going to have to take a picture of it, or you're going to have to scan it in or do something like that. You have to draw your stuff. So all of those things that you've been resisting for so long, those are the things that you will be graded on. So much like life. Here we go. So this is the forces that are on C. Oh, wait. I already drew my free body diagram dot. I'm more prepared than I thought. I'm going to get, this is the force on C from B. And I'm going to get attracted this way. This is the force on C from A. So now I've got to go back to figuring out what goes where. On this one, this was a preferential axis. I liked how those two canceled out. There's got to be a preferential axis here that will make that cancel out, because all I'm looking for is magnitude, not direction. So I have a feeling that if I go, I come off, wait, how is this one? This, we put this axis here, the point towards the middle. I bet, let's use this axis. So there we go, which splits the difference. So I'm going to make this way my X, and because both of them are pointing down, I'm going to make this one my positive Y. And I believe that makes this angle and this angle the same, and those are 60-degree angles. Does that kind of make sense? So here we go. Kind of have to just cock your head a little bit and then go from there. Where am I? Forgot to grab a... So here we go. Let's start in the X direction. I'm going to change colors here. Some of the forces in the X direction are going to be, you can see that as I go, I'm going to have this way and this way. It's going to be just like the sum of the forces over here. That is the equivalent of this one and this one. I have them pointing in opposite directions. That's going to end up being 0. So real quick, I'm going to FCB in the X direction, FCA in the X direction. FCB is positive. This one is negative. That's it, that one and that one. You can see that those are going to cancel each other out because I set up my axis accordingly. So in the Y direction, I'm going to have, in the Y direction, I'm going to have this one and that one. So those two are going to both add up, and I both set them up in the positive Y direction. FCB in the x direction is going to be FCB. I want this part. So that's cosine 60. FCA in the x direction is FCA cosine 60 as well. And here we go. The add those two together. I should end up with the same number, the same magnitude as I got for here, because FBA and FCB are the same, because the Q's are the same distance away. And then the sum of the forces in the y direction are going to equal FCB cosine 60 plus FCA cosine 60. And I don't remember what that turns out to be. But we can do the previous problem. We can plug that in there too. Those are the same. Yeah, those should all end up being the same number. Tisha's question about, are the web assignments still going to be due? I wouldn't be terribly worried about the homework. However, the question is about even if they're not covering the AP exam, go ahead and read that press release. Where's my light? No, not really. There, how about that? So they're going to cover it as much as you can kind of get as what they assume most people got through early March, and probably lightly put some other stuff on there. Maybe, I don't know. We did get a little bit behind, so I know I want to at least get us through circuits. And if you're at this stage, if you're really worried about homework, stop worrying about homework. There's bigger things happening. And now just focus on your own learning, because you're going to use this stuff later. It's not like you're never going to do circuits. So I got another problem coming, and then we'll get to chapter 1 through 7. Do you mean units 1 through 7? I will double check that. This is all very fluidy. And I checked if they had no supporting documents. So, okay. Let's shift to the next question. I don't know, I kind of like my chains. How many chains is it? Is he even still around? Katisha said, no electricity or circuits, only up to torque. All right. Well, I wrote this problem out. We'll just work ourselves through it, and we'll see what happens. Definitely we'll be there next week, Wednesday. That's going to give me some time to readjust some things. Also give me some time to get better lighting in here. What else? Yeah, and then possibly set up a little bit of home, some simple home labs you might be able to do. We'll see. We'll get as far as we can. We're all in this together. Well, I'm out in my shed or brewery. Here we go. This was a question from, who asked this one? I'm going to need 2 screens. From Ratika. Ratika, this is question on your website. It's number 11, but if you want to look it up, it's chapter 18, number 25. All right. technically we are all in this alone. Thank you, Sparsh. Remember, technically correct is the best kind of correct. Place a charge at P to make the force on particle A vertical. So that means to make the, it should be net force, by the way. The net force on A vertical. I was just thinking about this. This is free body diagrams. This is all review from other forces. So if you can draw the free body diagrams on these and just look at the forces, do the sum of the forces, what are the things that you need to be able to do? It's the same, right? It's all we're doing is shifting the stuff. As opposed to charge, you're going to be dealing with masses. As opposed to electric fields, you're going to be talking about gravitational fields. So it really is when you're thinking about in that field theory concepts, where it is stuff times charge, stuff times field, stuff times force, then it really doesn't matter what the stuff is. All right, here we go. So I want to make the net force on a vertical. So my end goal is to make, right, to make it look like that. So let's see what we have and how we can get ourselves there. I'm just going to draw my forces on my little dot here. So that is repelling. That is repelling. So I need it to end up this way. Just in the vertical, there's no magnitude here. So let's do this in this order. Let's figure out what sign we need, and then we'll figure out the magnitude. So sign-wise, if I put a positive charge here, that's going to repel, and that's going to give me a push in that direction. And so I still have, all right, that doesn't end up vertical in any way, shape, or form. When we say vertical, we really mean no horizontal components. Horizontal, L is not crossed. So I need to cancel out this one. This is the one I need to make go away. This one's already vertical, because when it says vertical, it doesn't mean up or down. The long side is 4D. Oh, I haven't put it up there yet. So actually, it doesn't really matter. My sides aren't the same. Yeah. Yeah, the picture looks like this. You guys are hilarious. Yeah, this is 4D. And this is 2D. Or this is just D. There we go. Although technically, because it's on the paper, it's all 2D. All right. Oh, that was yesterday's coffee. Yeah. I can tell it was yesterday's coffee because it has a big old 4 on it. Yesterday was the 4th day. So I want to make sure there's no horizontal components. I'm trying to make this one go away. That means I need something with something pointing that way. When I put a positive charge there, I end up with something in that direction that does not cancel that out. And in fact, it adds to it. So I need negative charge. So I got the first half. The sign has to be negative. The sun is going behind a cloud and I'm losing my natural light. And one of my light bulbs just went out. I'm going to have to brave going to the store. Okay, so here we go. So this has to be negative. I'm going to end up with the force from my charge in that direction. And really, I don't care about the vertical part. I only want the horizontal portion I'm going to change colors. I only want the horizontal portion to cancel out. So I only want f of p in the x direction to equal that one. So in order for this to be f net this way, I guess, or technically it could be f net this way. But then it's the same. So I want no horizontal components. So that means, therefore, the sum of the forces in the x direction has to equal 0. Let me put these on there. So FP in the x direction has to equal P in the direction, and then F from that other charge, I'll call that, that's a B. FB in the x direction, so when they add up, they have to equal 0. Hey, look. So FP in the x direction has to be the negative of FB in the x direction. Good thing. That's how we pick that negative charge as well. So here we go. But I've already. All right. So if I make this way positive, that way negative. There we go. Let's get rid of that. So now they have to equal each other. So, okay, Q1 or QA. Actually, no, it's QP. QP, QA, all over the distance between them squared has got to equal K QB, QA, all over, it's PA, the distance between PB squared. All right. So now let's plug that in. K's drop out. Charge of A drops out. Yeah. All right. Now I know Q. No, I'm solving for QP. All right, place a charge. That's QP. Solve for QP. I'm gonna bring this up here because I've got more space. So let's see what we got. I end up with QP. The radius from P to A is this distance here. Oh, Pythagoras. Okay, so this is root 4. Oh, I'm gonna walk that in square. Nice. So root 4D, 4 squared D squared plus D squared. That whole quantity squared has got to equal QB all over this, which is 4D. So then that becomes P squared, that's just 4D. 4D. All right, did I do that right? I think I'm doing that right. Double check. All right, quantity squared. Yes, yes. All right, let's mathinate away. QP, those two cancel out, end up with 4D squared plus D 16. D squared plus D squared equals QB 16D squared. Solve for QP. QP equals QB. That is 17D squared. 17D squared all over 16D squared. Yeah, then the D squareds cancel out. Nice. Yay. All right. Oh, let me plug the numbers in for those of you who like that. So QB is, plus 3 microcoulombs, 10 to the minus 6th times 17/16. Yeah, 3 e to the negative 6th times 17 divided by 16 equals 3.18 times 10 to the minus 6th. Let me see how close did I got. All right. Any other questions? Atiksha, can you do one of those electric field questions like number 22? Yes. I think that I can. I think I can. I think I can. I think I can. Oh, crud. Can I figure out what the number 22? I'm loading for the questions, waiting for the questions to load. Oh, 22. All right. So here's your web assignment number 2. This is chapter 18, number 74 in your book. All right, so we have a line of charges. So we have A. Oh, they're all separated by D. These are all positive? Positive, positive. Oh, the last one's negative. All right, and this is A, B, C, D. Okay, so now the question is, they all have equal magnitudes. Why do they? So they all have Q. All right, that's plus Q, plus Q, plus Q, minus Q. Is that kind of what we're talking about? No, not 22. It's just electrostatics. That's true. Yeah, I was wondering about that. Look at number 20. Look at me. Look at me. Look at me. Look at me. Number 20, the small drop of water is suspended motionless in air. Oh, that one? Okay. So this is chapter 18, number 66. So if a small drop of water suspended in the air by an electric field is directed upward, what's the mass? Is your mass of the water drop? Okay. How many more electrons are on it? Well, so let's draw the free body diagram. Yes, that really should be the first thing you always do. Draw that free body diagram. So I've got this drop of water. Drop of waters are, I'm going to need a second page. Is really what I'm going to do, because I need. Water drops are spherical. They're not drop shaped, despite what the artists tell you. So draw your free body diagram. What do I have? I have the force of gravity down. I have, it's suspended in air. So that means the sum of the forces on it have to equal 0. That means this has to get canceled out. There must be another force on it. What direction does it have to point? It has to point up. So this is the electrical force that's on it. So if I make up positive, sum of forces equals 0. So I have negative the force of gravity plus the electric force, and then that's got to equal 0, so the electric force has got to equal the force of gravity. And then and a uniform electric field that's directed upward. So let me draw my field in there. My field points so there's my E field. What direction does the electric field point? Electric field points in the direction a positive charge will get pushed. When I went back in to get my whiteboard and all my other stuff, I did not grab my practice little positive charge. So the electric field points in a direction that the positive charge would get pushed, or the positive charge would feel a force. What if my field points up and my electric force points up? The charge on this water drop must be positive. So you can't really see that. Let me switch that around. The electric field points in the direction a positive would get pushed. The water drop is pushed in the same direction as the field. Therefore, the water drop is positive. I thought I had a red one floating around somewhere. That makes it positively charged. And then the next question is, how many, there's probably another step that I should probably put in there. Field points in the direction, the net force on charge is 0, on drop is 0. The electric force is opposite the force of gravity. So therefore the water drop is pushed in the same direction as the field. Kind of need some more pieces in there, especially as you're going to be writing these things out. So now the question is, how many extra electrons do you have? So how many extra electrons do you have? So the charge on the drop, so let's see here. So the charge on the drop, so the question is, how many electrons do you have? The charge on the drop is the number of electrons that you have times the charge of the electrons. So I'm trying to find N, the number of excess, or actually removed electrons, because extra would be negative. I had to pull them off. So I need to find the charge of the drop, and then and that's going to be divided by the charge of the electron. So what am I going to end up with? The charge of the drop. Well, now I have to go up to here. This is going to be the force of the electron. So remember, field force is stuff times field. Do I get the electric field? It's a uniform. Oh yeah, I get the electric field. Nice. So this electric field is 8,600 newtons per coulomb. So force is field times stuff. Electric force is stuff, charge, times the electric field. So this turns into QE. What's the force of gravity? It is stuff times field. It is stuff times field. So the charge that's on that drop is mg divided by E. Divided by E times the charge on the electron. All right. There we go. All right. Our half hour is up. That should get you to where you want to go. So you can check in. I will be checking in on School Loop, also on WebAssign to see which questions you want to go back and look over. Oops. Go ahead and let me know which ones are going to be working, which ones you want to try out. I will do some reviewing. We got to keep our eyes out on AP Central, as again, all of these things are fluid. Let me plug those numbers in for this one problem, just so you can kind of get the idea of what is where, and then we'll close out. So on my problem, the electric field's 8,600. Oh, it's right there. So, and mass of my drop was 3.45 times 10 to the minus 9 kilograms. G is 9.81 because I'm feeling pedantic there. Number 8,600 times the charge of the electron. And I got all excited. I brought my sheet back with me. The charge of the electron. 1.6 times 10 to the minus 19th. 1.6 times 10 to the minus 19th coulombs. That's newtons per coulomb. And that's newtons per kilogram. All right. And I should end up with kilograms canceling out. The newtons cancel out the current because I just want to number how many electrons. All right, cool. With that, as you're going out and about, especially now, it's going to start getting a little bit wonky. People are starting to get stir crazy. And be kind and see if you can help anybody out there. So Kaylin asked, is there anything you can post on AP Classroom for us to review earlier units? I will check that out. Let me write that down. Srikar, of course, asks, do I have to go back to school? Well, I'm pretty sure that it's going to be fluid. And meaning we don't really know. Right now, the assumption is that we will start on, we're going to go back on the 13th. So operate on that assumption. Right, again, today's truth is we're going back on the 13th, and we'll review and kind of go from there. Keep your eye out on the news. Keep your ears out. Watch read your emails. So, do I have lectures on mechanical waves that we could use? I think so. We will kind of we'll go from there. And do you leave your live stream videos up even after ending them? Yes, I think, YouTube does it anyway. And, what was Kaylin's question? What can I post on AP Central? I will try to find some other problems. I also think too, I'm going to find some questions out of the book. I'm going to find some released AP questions that I'll walk through. We'll just kind of walk through how we solve them, and don't panic. We'll be fine. And just like Sparsh says, we're all in this together, apart. All right, we'll see you later. Bye. Okay, how do I turn this off? Bye. Nope, try it again. I've become my parents. How does this work? Yeah, what? Is this thing still on?